This episode of Liquid Assets is sponsored by HASA, the leader in water treatment solutions. HASA delivers eco-friendly, reliable, and cost-effective water care and has been keeping communities safe, one drop at a time. They've been at it for more than 60 years, and you can learn more about HASA by visiting hasa.com. That's hasa.com.
The way the bubble moves, it does like this like brownie movement, like which is similar to like molecule, like moving like side to side, top to bottom. So like bubble is like actually like moving kind of like this, like just like vibrating, like moving around. That's why it can stay in water like very long time and eventually go underneath the dirty thing, because the way we generate the bubble, it has the negative charge around the bubble, and most of the dirt or like surface has plus. So dirty thing like goes under, and then the bubble can eventually like go underneath, and then like when there's a flow of the water, like it can like cleanse it off.
I'm your host, Ravi Kurani. Liquid Assets is a podcast that talks about the intersection of business, technology, and policy, all as it relates to the world of water. Today, we have an amazing guest for you. We have Natsumi Ito.
Hi, everyone. I'm Natsumi, co-founder of Water Design Japan, and we solve clog pipe and damages without using chemical with the technology called nanobubble.
Natsumi, how are you doing today?
Good. How are you doing?
I'm doing good. I'm doing really good. You said, what time is it over there? You're in Japan right now, right?
Yeah, I'm based in Tokyo right now, and currently 11 p.m.
11 p.m. Okay, it's 9:30 p.m. or 9:30 a.m. here in New York City.
Yeah,
So,
and you still in Wednesday, right? Oh no, it's Thursday too.
we're in Thursday now. Yeah.
Okay, so we're on the same day at least.
Cool. Why don't we jump off? We had an awesome conversation when I saw you last at the Consumer Electronics Show in Las Vegas. We have a ton of stuff to talk about today. And so I think what we should actually jump into is let's just get down to the meat and potatoes, right? Let's just kind of open up with who you are, what you're working on, and let's just jump right into nanobubbles, because nanobubbles is the theme of today's conversation.
Yeah. Well, thank you so much for having me today. My name is Natsumi, co-founder of Water Design Japan, and we do a nanobubble technology. What nanobubble is pretty much like a very small, tiny bubble. It can last in water up to 1 to 2 years and bring a cleaning benefit. So our goal is essentially to reduce the amount of the chemical from industries. And our solution is like very simple, like this, just the tiny nozzle. This is the smallest one, and this was the one actually we were showcasing at a CES. This one you attach to a shower head bottom, like through the hose, and when the water passed through, like you see like the inside, like a little like a structure. This is the core element, and it doesn't reduce the water pressure. And then when water get through it, we transform what's existed in the water into a nanoscale. So we're not changing water quality, purify anything. So our core technology, which is like more like bigger one, like we have been like introducing like this bigger guy like to industrial application, like has been used like more than 10,000 location like all around the world right now, and we have been able to reduce the chemical amount or like reducing the water usage by improving the like filter efficiency and so on. So yeah, like that's what I do.
I want to kind of go back, and you guys make tiny bubbles that last in water for about 1 to 2 years, you said. What is a tiny bubble? Like, is this like when I turn on my tap and I, see the bubbles that are coming out? I'm just going to kind of ask the stupid questions because
No, it's fine.
how does it work? Like how big are these bubbles? What's going on?
Yeah, so like I say like it's a nano bubble, and like when people hear like the bubble is like probably like oh, like it's like you can see with the like visual eyes, but like nano scale is like really really tiny, so you cannot see like even like when we generate the like water like pass through like this like nano bubble water, like you don't see the bubble in the water. So the water that we drink every day, like it has like H2O, like so it has the air already inside. And we just simply like pass through this nozzle to create what already exists in the water into a nanoscale. So we're not changing the like water quality, like purify or anything, like just simply like what we're just using what's already existent in the water into a like smaller scale. And nanoscale is like really, really, really tiny. Like I think like everybody remember during the COVID time, like the COVID virus is like super, super small, about the same size.
Okay. So you had mentioned that there's already air in water.
Hmm.
Water is H2O, right? Two
Yeah.
hydrogen, one oxygen. When the water is going through your device, an nanobubble device, are you like, are you injecting more air? Like how do you
No.
get more air? Or how do you take the air that's already in there and make it tinier?
So like we just simply using the water as the ingredient, like as a like, like things to like generate. We could have like a different inlet to like have like inject different type of like gas, like oxygen or like a CO2 or hydrogen and things like that. But we don't do that. Like this one is like simple like nozzle, because there are a lot of ways to generate a tiny bubble, like not like especially like nano bubble, micro bubble, fine bubble, like those category. And when you inject gas or like outdoor air, it causes the contamination in the water, and
Sure.
especially in the sensitive places like medical or like semiconductor, like those places, you can't do that. So those place is the like actual like place where people is like facing a lot of like chemical usage, and like they want to reduce the water like usage and then all that. So our solution is the only one has been able to like use in the medical and like those sensitive places.
Awesome. Really cool. So kind of backtracking for the audience, you guys have a nanobubble technology. You're able to just basically take the existing water, tap this onto a pipe, and there's no pressure decrease. So you're not like changing the
No.
flow rate. There's no decrease in the speed of the water that's flowing through the pipe. Um, and then basically you take the existing water that already has air inside of there,
Mhm.
and you just make tinier bubbles out of the already existing bubbles that are there. And this, you said, helps keep the water cleaner, or like what's the kind of end goal here? You had mentioned kind of hospitals and
Right.
your different applications. Like how does it keep it clean if you're just introducing more, not
Right. Right.
introducing more air, but making tinier bubbles?
Thank you. So this like device is not a filter. It simply generates the tiny bubble, which is the nanoscale like nano bubble. And when the nano bubble becomes like a scale of like a small, small, tiny like nano bubble, like it, like when you buy the sparkling water,
Hmm.
the bottle, like you open it and then like it makes the sound like, and then like you see the
Yeah.
bubble like goes like up due to gravity.
Yeah.
And like the normal like those like bubble that you can see in the water like visually like usually like floats on the surface like around like 8 to 10 seconds. And when the those like bubble becomes like more like a micro bubble, uh you will start seeing the bubble is like in the water, like kind of like water becomes white. Like when you generate, like the water becomes like a white, like a silky water. That's like a
Hmm.
micro, but like it still does like gravity movement. So like flow like from bottom to top. So it moves slowly, but like around like 12 to 14 minutes around, and the bubble will like it eventually lose, and then like the water becomes clear, and then those like bubble loose. But nanobubble is really, really small and tiny. And an interesting characteristic is that like the way the bubble moves, like it doesn't like go floats on the like due to gravity, like this like bottom to top movement. It does like this like brownie movement, like which is similar to like molecule,
Uh-huh.
like moving like side to side, top to bottom. So like bubble is like actually like moving kind of like this, like
Yeah.
like a star, like just like a vibrating, like moving around. That's why it can stay in water like very long time and eventually go underneath the dirty thing, because the way we generate the bubble, it has the negative charge around the bubble, and most of the dirt or like surface has plus. So dirty thing like goes under, and then the bubble can eventually like go underneath, and then like when there's a flow of the water, like it can like cleanse it off. So
Ah,
that's
interesting.
why nanobubble can, it's not like 100% alternative of the chemical, but we were we have been able to help the industry or like a home usage, like everyone to reduce the amount of the chemical, like let's say like for home, like detergent usage, or like the how frequent you clean the pipe, or like
Hmm.
how frequent you clean the toilet. Like when you don't clean, like there's like a black thing, like black ring created due to a biofilm. Like those things, nano bubble prevent it. It's not going to be 100% alternative. Like you still have to clean, but like a cleaning term tend to get longer, or like the amount of the chemical you use tend to get reduced. So that's
And what are you seeing in terms of reduction of chemical use? Like if you were to pick an application like washing detergent or your toilet, um, what were you doing yesterday? And then if you had nanobubble technology on there, what are you seeing today?
so for detergent and stuff, it's like hard to say because like depend on the household, like the amount of the detergent that they use is difficult. I mean like different. So I always give you like example of that more like the industrial side.
Sure.
And we use it for dialysis for medical device cleaning. And we were able to reduce around like also like scale this hospital as well. Like some hospital has like 100 like beds or like 20 beds. So amount of the chemical that they're using is like very different, but around average of like 60% chemical reduction per month. And
Wow.
that was a lot. So and this is also like one-time purchase. And most of the like a case, like return on investment, like close it like around like 2 or 3 years. And
Wow,
another
that's
case,
amazing.
like we also use for like lately we've been testing for like semiconductor. This is not for like reducing the chemical, but they had a lot of people in line for cleaning, like picking up the packaging, like chips, like one by one. And then like
Mhm.
human is like using the swab to like clean the surface because the cleaning failure was like so high. So they have to like manually, like human is like cleaning. So we use in that line, and we improve the cleaning efficiency by up to like 92%. So instead of having 6 people in line, like we were able to cut just one person.
Oh my gosh,
So
that's crazy.
that reduced a lot of labor cost.
And so
So
if I understand correctly, like just taking like kind of the toilet example or the dishwashing example, just for the sake of kind of the audience being at home, um, the the nanobubbles basically have a negative charge as they go through as they're
mhm.
generated. Generally, biofilm or trash or like dirt have a positive charge, and so these nanobubbles basically go in and kind of like separate out the trash or the dirty stuff, the biofilm from the water, and then basically
Yeah, more like surface, I think.
okay, and then the detergent otherwise would be basically doing that job, and so it's actually like assisting the detergent in doing its job, and so you would have to basically you would use less detergent or less soap or less cleaning needed.
Yeah. And also like more like longer you use the nanobubble, nanobubble is like invisible bubble, but like it also like coat the surface and it stay on the surface level as well. So more you use like nano, like you have to like try to like spray the water more, like not like just one spot. Like you don't like spray the water like everywhere, but like if you want to like have like a benefit in the shower room, for example, you have to like on the like wall or like a mirror and then like everywhere. And nanobubble will coat the surface. And after that, um, scaling or like sometime like mirror like build some like scale to like become like start to become white, or like the floor gets like a pinkish like slippery thing like all of those is like due to biofilm, and
Mhm.
those tend to coat it by the nanobubble, and then it get clean. And after nanobubble is cleanse it and then like clean, it prevent the biofilm to grow faster, or even if the biofilm grows, because nanobubble is there, it becomes kind of like a cushion, so it's
Yep.
easier to like clean after. So we seen
Wow.
the customer like they were facing like a hard scale issue, and after using nanobubble becomes like more soft scale. So like not like instead of like rubbing hard, like just like a sponge wipe and like easy to like do the maintenance.
And how many, like, I assume there's some sort of density required of nanobubbles created inside of a bucket of water, you know.
Hmm.
Um, I know it's going to depend on how big the surface area is on the wall, but like if you can walk us through an example of like, you know, you need 5 gallons of water to do, you know, 20 square feet or whatever in meters. What does that look like? What is like the equation of how many bubbles you need? How long do you need to run this attachment that you have to generate the right amount of bubbles to then like coat the wall? And then that lasts for like 2 years, or every 6 months or 3 months, you need to kind of recoat it. What does that look like?
So like just our nozzle, like it's considered as the water pipe, so you don't need to do maintenance or anything. And how much bubble needed in order to have like XYZ amount of the cleaning benefit, that's something we are trying to map it out to like figure it out more like closely as well,
Mhm.
because nano size bubble is like really really tiny, and there's like a world class like a standard like observation unit exists, but the area that they were trying to look at is really, really tiny. So in order to use those machines to get the right data, like you need to like circulate, like let's say like you have to like circulate like multiple times to like create like more higher density of the bubble of the water.
Mhm.
And then if you are lucky, like the bubble will be like captured and you can count it. But that's not ideal in the like real lifetime. Like if you are using at a factory or like place like you want to like check it every time. So we partner with one of the engineer company, and we developed the observation unit as well. So that's something like we are trying to figure it out. But as far as we learned so far, higher the bubble tend to bring more cleaner benefit.
Really interesting. And so I guess just kind of digging into something you said earlier, like I know the observation unit, as you were saying, needs like a closed loop until you have a certain amount of bubble density. But if you're in this restaurant setting again, right? Like we're kind of going back to that biofilm on the wall or biofilm on
Mhm.
on the floor. Um, do you need to kind of like do you see applications that have like a closed loop and it has to like, you know, run in the closed loop for 30 minutes or something, and then you can kind of unleash the water because it has a high enough density? Or do you just put this on the pipe and then just basically start spraying?
For the like a standard homes or restaurant, like dentist, like hair salon, like all those application, like we don't do the circulation, and we have the customer like is very happy, and they've been like using for quite a long time. And those application, you simply this is like a water like nozzle like connector pretty much. So you
Mhm.
cut the pipe and install it. That's it.
Really cool.
Yeah. So
That's
it's
so
very
awesome
simple.
that you don't have to like add any chemicals. You're just changing the consistency or the size of the air in the water to basically get it to be able to be more efficient.
Yeah, because I think like nowadays, like everywhere in the world, like we want to clean thing, and we have been using a lot of chemical, like even for pool, like chlorine to like like sustain the like a cleanliness of the water. But is it actually that much necessary? And then if we can replace it, something that we have been already producing, which is like water, like has a like air in it, and then we just change the like the size of the bubble, like simply, then that might be better. And our goal is to like reduce the chemical amount from the industry like around the world, and like not
Mhm.
to just like sell it to like whoever just want it, but like we want to find the actual place who's actually looking for this like kind of solution, because Japan is really like clean water, and then I think we are rich in terms of like a water like natural sources and all that, but around the world is like different story, and a
Yeah.
lot of places like facing like hard like water issues and things like that. So we want to help those like places to find where is the actual right place to meet looking for this kind of like solution.
Super, super inspiring. Um, let's go back to the founding story. I'd love to understand what makes Natsumi tick, right? Like, why did you're one of the co-founders, like walk me through the kind of origination story of the company, and let's learn a little bit more about you.
Okay, so I'm one of the co-founder of Water Design Japan, and I was always looking for a technology it can apply for like global scale to solve the global issue. And I'm not the like technology founder of the nanobubble itself. And the actual like product founder of is ex-CEO of Mitsubishi Chemical Company. He's like heavily like knowledge about like water and like engineering and like he expand the water purifying machine in entire Japan pretty much. And he was selling like a water purifying machine, like which is like more like a cartridges, right? And after World War II, like our like Tokyo, like Japan's water, like needed to like filterize because the amount of the chlorine the government was using was like more higher. So the taste of the water was different, and then like those like purifying machines was like needed like from the like, customer side. So like it expanded more and more, but like um, like time passed it, and then like government's like a water treatment like system and everything like got improved. So it's not that much necessary to have much of a like a filter replacement, but just the size of the business, like cartridges like changing and then like keep like kind of like subscription. That was the business model, but it's not that necessary. So he wanted to, after like he retired his like Mitsubishi's like position, like he wanted to actually found and like leave something good for the future, which is nanobubble technology. Because like around like early 2000, this nanobubble technology was heavily studied, like started off in Japan. It was by the oyster farm. Like we have like one of the like biggest oyster farm in Japan, and one of the prefecture called Hiroshima. You might know. And Hiroshima has like one of the big oyster farm, and they had the Red Sea poison issue, and all the oyster died, and they had like a 40 something million damage. And that time, one of the professor got an offer to install a microbubble generating solution, and somehow it worked. And that's how the tiny bubble research started. And Japan was like, even the government was like a hype, and then the government invested around like 2014 to accelerate this technology to grow. So around that time, a lot of like researcher, and then like generating solution maker, scaling machine maker, like these three stakeholder like try a lot, and a lot of like research paper and all that thing like publish. And that time was especially in the like a plant science. And so that's why outside of Japan, a lot of people see the plant science application, like the plant growth, and then like aquaponic, hydroponic. We see the result and we hear from the customer, but we couldn't actually see the nanobubble to figure it out how exactly the roots is growing faster, or like why the fish gets bigger, or like why the shrimp gets healthier, or like all those things. Like still you get the result, but like questions.
Mm-hmm.
So we our like product founder, he still like went on the like research and all that to figure it out, like it might be actually useful more for like a cleaning benefit. And then he had a lot of like connection with the medical field, and because like this was it's patented, and also water supply certification and passing the drinking water testing, everything done. But it doesn't says like even if you have all those like app certification and everything, it doesn't promise you it is generating nanobubble, because there's no such organization is like like claiming like oh like you generating this much of like a nanobubble or nothing like that. So it was difficult to like get like buy the like trust from the customer. And like it was like like the beginning of the water technology is always like kind of like a sketchy. So that's why he did the testing in the medical field, and it was published at the doctor conference. And then we start introducing for the household and like individual, like those like consumer side. And I met the product founder and our like CEO. Like so like we are like three of us founded together. And it's funny, like our age difference is kind of like a 3 generation difference. Like I was in my 20, and then our like my partner is like he was in his late 30, and then the product founder was in his late 60. So now like
Oh, wow.
everybody's like, and we next month gonna be our fifth year closing. So we all going into like 6 years. So like everybody's like 70 and 40, and then I just turned 30.
Mhm.
So it's kind of like a like dynamic
Yeah.
difference.
Yeah.
And at the beginning, like they were like, "Who's this girl?" kind of thing. But I saw the potential of this technology, so um, I pitched them, and I took them to like a pitch competition, and then winning, and um, that's kind of like how we started. Like I think it's kind of like a weird way, like an interesting way. Like it's not normal. Like I was like doing a study or anything. It's more like I was like looking, searching for like a different type of technology, because I did grow up like outside of Japan, and I did see the uniqueness of Japan as a Japanese when I came back to Japan from abroad. And Japan is unique, and someone needs to be the bridge to like close that like gap as
Yeah.
well.
Where
So
did
I
you live prior? And can you like, what did you, what differences did you see outside of Water Design Tokyo and this nanobubble technology in the delta or the discrepancy between where you were and what Japan has?
so I grew up in Taiwan, and I went to school in the US. And with my previous job, I was like traveling to like San Francisco Bay Area a lot, and like back to back. And like nobody knew about like this nanobubble technology, first of all. And but like at the same time, like Japan kind of like started to having like the bubble boom. Like it was
Mm.
starting, like this bubble boom like started in the past, I would say, 4 years. There's like a three shower head maker
Okay.
created like there's like a three like big ones. Now it's become more like a two, but like they created the $100 million market in a year. So like the nanobubble technology was like always like having the hype, like everybody was saying like, oh, like it might be like a big potential to create like a big
Hmm.
market, but it didn't. And then finally it kind of like hit with the shower head. And I was seeing all that, but like outside of Japan was like a complete different story. Like nobody didn't know anything about nanobubble.
And what else did you see outside of nanobubbles in the US, Taiwan, that like are opportunities that you see in Japan? Or it could even be cultural. Like, is there any other things that stuck out?
um I think like Japanese people is really good at like kind of like focusing on one thing, continue to like do like like teamwork to like a research type of thing. So there are a lot of good technology out there, and then like but also at the same time sometimes it kind of like hard to ask them to like share all the data and everything. Taiwan, like Taiwan and Japan, like country and country wise, like I used to live there, and then my father was like a founding member, like back in the time to like open the like Taiwan branch. And like, Japan like was, like taking over like Taiwan and like back in long time. And then like some like elder people like still speak Japanese, and then like it's like a good friendship, I think. So as a Japanese, I go in Taiwan and then like trying to do business. It's not that hard, but like the language is very different still. So understanding the market is different. But I think US is like way like more different like story, like the way the marketing works, or like how like people always bring in the technology. And like especially on the startup like scene, like it's kind of like like fast growth, like kind of
Hmm.
like bootstrap and all that. And as a like more hardware startup, we call it like us like as a startup because like the government is also like pushing the startup scene. But We were kind of like a slow at the beginning, and now like trying to like growth now. So just like seeing like the differences, like the cultural like dynamic and all that, and also like hearing the BC from there, like the perspective of Japan, like Japanese people like difficult or like not good at like expanding, especially like global expansion, because like Japan is kind of like a Galapagos island, like very different, and the language is different, culture is different, like business culture different, like all those things. And it's pretty much the bridge to like share to like all my team to like have them also understand, because like it can be like like changing like someone like a old like a person's like mentality like right away.
Sure.
um
Yeah. Really,
so
really
yeah.
cool. Now, to me, what are so you guys had mentioned that you have a shower product, and then you're selling into medical. What are the sweep of like applications that you guys have in Japan?
So Japan's biggest market is home application, actually. Yeah. Uh, about like 60 to 70% of our revenue come from household
Mm,
application. When people build a new home or like renovation, we work with a lot of like a developer, like a house maker,
okay.
constructor, like design houses, like those people. And like customer, like they cannot do a DIY, like they have to have a plumber like who has the license to install it. So like that's how we work with those people to like kind of like a B2B2C application. And
Yeah.
if they have a like customer, like they tend to like also like work with like Japan is small, like it's not like a US, like Japan is the size of California pretty much.
Hmm.
So a lot of like building like apartment, like all those things is like very accessible. So like they tend to like also like do like hair salon or like dentist, like all those like buildings. So that's the like biggest application. But we also getting a lot of industrial side, and we're trying to collect more data on that side as well.
Really cool. Awesome. Thanks so much for joining us on the show, Natsumi. Um,
Thank you too.
if people wanted to find you, where can they find you at?
You can find me on LinkedIn. I think that's the easiest place, or you can find our company website.
Awesome. Thank you so much for coming on.
Thank you.